You are expected to convert from degrees to radians on the SAT, and they do mention on the formula sheet that a whole circle represented in radians is 2 pi. So let's see how we can use that information to help us. We know, or in this case, we're expected to convert 80 degrees into radians. So let's represent 80 degrees as a fraction out of a whole circle. And we should know that a whole circle is 360 degrees. Now we can use that information from the formula sheet to create an equation. This fraction that we just set up is going to be equal to an unknown amount of radians out of 2 pi radians. 2 pi represents the whole circle, just like 360 represents the whole circle. And the unknown is our actual answer. That's turning 80 degrees into however many radians that we have. Now that we have an equation, we can solve for x. I'm going to do so by multiplying both sides by 2 pi. We have 2 pi times 80 over 360 equals x. I'm going to simplify that fraction. 2 pi equals, times 2 over 9 equals x. And then I'm going to multiply the 2 pi to the numerator. 4 pi over 9 equals x. And that's our answer. 4 pi over 9 represents 80 degrees. So if we have to convert 180 degrees into radians, we can use the same equation that we just used. It's 180 over 360 equals x over 2 pi again. And we're going to do the same process. I'm going to multiply the 2 pi over to the other side. Now I can quickly see that this fraction simplifies to 1/2. So the 2's will cancel, the 2 on top and the 2 on bottom. So that'll just be pi equals x. So in this case, our answer is 1 pi, or just pi. Let's practice converting radians into degrees. We have 3 pi out of 2 pi. Again, because 2 pi represents a whole circle, is going to equal x out of 360 degrees of a whole circle. It's the same concept though, we just multiply the 360 to the other side. So we have 360 times 3 over 2, because the pi's will cancel, equals x. A lot of people will multiply the 360 to the numerator, which you're allowed to do, but it's also helpful to know you could divide 360 by 2 instead. It's your choice every single time. Most people just default to multiplying to the numerator. I know 360 divided by 2 is 180. And that's a little bit easier for me to do in my head. So if this is a non-calculator problem, that's an important tip that you should know for any free response question or any question at all on how to simplify these easier. 3 times 100 will be 300 plus 240, because 3 times 80 is 240 and 3 times 100 is 300. So x is 540. The equation that we keep using is really helpful for ratios as well. That's what I teach students in my boot camp. So if you want more videos on that, I have them linked below in the description. Let's multiply the 360 across. But actually, before we multiply the 360, let's simplify this fraction on the left-hand side. I know a lot of you kids are shivering in your boots right now with a double fraction, but just calm down and remember that this can be represented with a division symbol. Okay, the fraction bar just means to divide. So I rewrote that fraction with this big fraction bar being a division symbol. And now I can remember, I can tell myself, keep, change, flip. Okay, so I'm going to keep this first fraction, I'm going to change that division to a multiplication, and I'm going to flip this fraction into 1 over 2 pi. See, this becomes a lot easier to handle because now when you multiply fractions, you just go straight across. Okay, so I'm going to erase a little bit, but bear with me. We have 2 pi over 6 pi equals x over 360. Now really quickly, we could actually simplify that fraction. The pi's cancel and 2 over 6 is 1/3. And now we have 1/3 equals x over 360. Now we can multiply the 360 to the other side and easily solve for this missing variable. 360 over 3, that's going to be 120. X is equal to 120, 120 degrees. This is how the SAT makes these conversion problems much harder. They gave us a radian, and they're explaining to us that it's expressed as a degree out of 360. Nothing new to us so far. But now they're saying that the fraction is expressed as a over 2. So our final answer needs to look like a over 2. They want us to find the value of a as our final answer. Well, right off the bat, all I want to do really is actually convert pi over 4 into degree. Once I do that, I could kind of understand what they're saying. So instead of panicking, I'm just going to do what I've practiced, which is pi over 4 over 2 pi equals x over 360. It's the same case. We have pi over 4 divided by 2 pi over 1. That's going to become times, and that's going to become 1 over 2 pi. So the pi's cancel, and we have 1/8. 1/8 is equal to x over 360. Understand, I just rewrote this whole double fraction down into 1/8. Okay, I'm going to multiply the 360 across. And we get this fraction here, 360 over 8. They said that my final answer needs to be represented as a over 2. So my answer is not 360. I'm not at the fraction that they want me to be in. Let's simplify top and bottom by 4. We're going to get 90 over 2 equals x. You see, I simplified the fraction. And now I have a matching denominator with what they want us to have. So I know a is 90. And that's my answer. Your answer is not 90 over 2. That's just the degree. However, they want you to find the numerator at this moment, at this point in time. So be very careful with how you read these problems and understand what they're asking you. This is a tough one for a lot of reasons, but let's break this down. We have 3 pi over 4, so we start off with radians, and it's represented as a degree. So I know we're going to be doing the same equation that we've been practicing at some point. Now they say that the fraction form is a over b. So I don't know either numerator or denominator, but that's okay. They're asking that, or they're explaining that a and b are positive integers. So there's no decimals involved, nothing crazy, no negative numbers. It's asking for a possible value of a plus b. This means that there's probably multiple right answers here, but if I do what I've been practicing, I know I'll find one of those correct answers. I don't have to find every single correct answer to get this question right, just one of them. So let's start off with our equation. It's going to be 3 pi over 4 divided by 2 pi. Equals x over 360. This is where we want to start off with to convert the radians to degrees. We get 3 pi over 4 times 1 over 2 pi equals x over 360. The pi's cancel, the 2 multiplies to the 4. We get 3 over 8 equals x over 360. So x is equal to 360 times 3/8. Whoops. I'm nowhere near my final answer yet. I have to simplify this into one fraction first. I'm not dealing with 3 and 8. I have to multiply the 360. So we have x equals, that would be 90 times 3 all over 2. You see what I did is I simplified the 360 with the 8 first. And that's how I got 90 over 2. Now I'm going to get 90 times 3, which is 270 over 2. Okay, at this point in time, I could stop myself. I know I could keep simplifying. 270 divided by 2 is, 135? So I know that that could be a possible answer, but they want us to represent this as a fraction. So I'm going to keep it as it is. They said that we have to find a plus b. Well, 270 plus 2 is 272. So that would be my answer personally. There's some other options that I'll go over real quick. If you continue to simplify this, you would get 135 over 1. Which means that 136 is another correct answer. Technically, if I didn't simplify the 360 and the 8s, and I instead multiply the 360 to the 3, we would have gotten a bigger number. We would have gotten, let me think about that. 3 times 3 is 900. 3 times 60 is going to be 180. So that's 1,180 divided by 8. So another answer could have been 1,188. So those 3 are correct answers for the same problem. I would have just stuck with 272. I practiced what I've been practicing for other problems, and I apply that to this problem here. It's going to make my life a lot easier when I can streamline the techniques that I'm using for these problems. Let's talk about special triangles. In this case, we have a 45-45 triangle, and this can be broken down in a couple ways. The first thing you want to know about a 45-45 is that those 2 other angles are going to be 45 degrees. They're matching. And what this tells you actually inherently is that the sides are going to be the same value as well. That doesn't mean the sides are 45. It just means whatever value you have for one side is going to be equal to the other. There's a special trick here about the hypotenuse. You don't have to do Pythagorean's theorem to solve for the hypotenuse. You just have to know that the hypotenuse is x times the square root of 2. And this is on the formula sheet. So let's do a practice problem about the 45-45 triangle. We're talking about a right isosceles triangle. So what does that look like? Well, we have two same sides. That's the word isosceles. We have a right triangle. And so quickly, hopefully, you could determine that this is actually a 45-45 triangle. You see, they didn't actually tell you that, but you're supposed to conclude that yourself. That means the hypotenuse is x squared to 2. Now, furthermore, they gave us a perimeter, 24 plus 12 squared to 2. And they want us to find the area of a quadrilateral made by reflecting this triangle over its hypotenuse. Before we try to digest all of that, let's just envision the quadrilateral that they're asking the area about. We have to reflect over the hypotenuse. So it looks something like this. As you can see, we end up having a perfect square. So we have to find the area of this square. But they didn't give us the perimeter of the square. They gave us the perimeter of the triangle. So we have 24, P equals 24 plus 12 squared to 2. And the original triangle, the perimeter would be all the sides added up together. So we would have x plus x squared to 2 equals 24 plus 12 squared to 2. The easy way to solve for this, to solve for x at least, is to understand the pattern here. We have two x's, and then we have an x times the square root. Just by looking at this equation and knowing that they're equal to each other, I know that x is equal to 12. So very quickly I could solve for this missing side on my whole square. You see, don't forget, we're trying to find the area of this square. So I know it's 12, I could plug that in. 12 times 12 equals 144. I multiplied the 12s, the sides of the square, because we're trying to find the area, ultimately. That's our ultimate goal. So my answer is 144. And this is a great free response question on the SAT. There's also a 30-60 triangle. And a 30-60 triangle is defined by a 30-degree angle and a 60-degree angle. They can be represented as standing up as well, kind of like this. What's important to know about these is the proportions of the sides. The smallest side is always across from the smallest angle in any shape or triangle. So that's going to be x. We let x represent that smallest side, and the proportions continue as x squared to 3 and then 2x. An easy trick that I use to remind myself whether it's square root of 3 or square root of 2 is there's a 30 in this triangle. So that 3 there reminds me to put x squared to 3. Whereas the 45-45 triangle actually has this x squared to 2. They gave us a diagram representing a rectangle being cut diagonally, and they told us some quantities that we can determine. We have line segment AB being 5 squared to 3, and the measurement of angle BAC being 30. So that's going to be 30 degrees right there. Again, this is key. These are key details for you as a student all by yourself to determine that we have a special 30-60 triangle. So if this side is 5 squared to 3, and this is the side that's next to the 30-degree angle, I know that my x value is 5. So if my x value is 5, my hypotenuse is 10. What's good to know is we don't really care about the hypotenuse. We care about the perimeter of the original rectangle that they gave us. So all I really need is the 5 squared to 3 and the 5. If I translate this onto the rectangle, we get 5 squared to 3, top and bottom, and then 5 on the left and right. So another question becomes, how do we combine these? How do we add these? We get 5 plus 5 plus 5 squared of 3 plus 5 squared of 3. You don't combine the 5s if they have a radical versus not a radical. So we actually don't combine those at all. The only ones we combine are the ones that match entirely. So we could combine the first two, giving us 10, and then we can combine these two, giving us 10 square roots of 3. Do not add the number within the radical. Links are in the description. Leave any comments if you have any questions. Thank you for watching. This is Dante with Path to Math. Have a great day.